Okay, welcome back. In this video, what we're going to be doing is looking at graphing day 2. And today is mostly review, but there's a few new vocabulary words that we're going to kind of throw into the mix. And then we're going to review some things as well that you saw way back at the beginning of the year. I think it was like either first or second term that we did it. Last time we talked about graphing circles, and today we're going to do some more circles, but we're also going to throw some parabolas into the mix, okay? So let's first look at these two that I have here. I have an equation x squared plus y squared equals 4. Now, last time we talked about what the graph of that would look like, right? That's a circle because we have this, it's both x squared and y squared equals 4, okay? What is the radius of our circle? Okay, when x squared plus y squared equals 4, it's, well, r squared is this part, the 4 over there. So r squared is 4, which means that r would be the square root of 4, which would just be 2. Okay, so the radius of our circle on this one is just going to be 2, and it's going to be centered at 0, 0 because there's nothing else inside with the x and the y. It's not shifted up or down, left or right at all. So our center for this one is just at 0, 0, and then it goes 2 away from the center in all directions, okay? And it is a circle. And I'm just kind of drawing in a graph here of what that would look like, okay? So it just goes 2 away from the center in all directions, and that's your circle, okay? Now, our big point today is we kind of want to see how is this different from what we did at the beginning of the year when we had parabolas. Well, if you remember y equals x squared, what does that graph look like? Notice this one doesn't have, like y equals x squared, doesn't have a y squared in it. This one has x squared plus y squared. The y is also squared as the x is. This one, it's just the x that's squared. The y is not squared, okay? So that means this is a quadratic equation. This is going to be a parabola. When you plug in 0 in there, 0 squared is going to give you 0, so it goes through the point 0, 0. When you square 1, 1 is the x here, okay? When you square 1, you get 1. When you square 2, you get 4. Okay, so 2 at x equals 2, you get out 4. And so what you end up getting is kind of this U shape here, and then it does kind of the same thing on the other side. You square negative 1, you get positive 1, and it will go like that. Okay, so this was called a parabola, right? And this was y equals x squared, okay? So we're going to kind of be graphing both circles and parabolas today and kind of doing different shiftings of them and kind of seeing what the graphs look like. And then also we're going to be finding domain and range, and that's kind of what we're going to be doing next. But how do you tell if something is a circle? Well, a circle was x squared plus y squared equals r squared, and then a parabola is just going to be like y equals something with x squared in it, but the y is not going to be squared, okay? Okay, so the y is not squared on a parabola. It's just the x that's squared for a parabola. Okay, so that's what we're doing here. Let's go ahead and talk about domain and range first, and then we'll do a few more examples where we graph some of these. Okay, let's slide this forward maybe. Okay, there we go. Okay, so let's look at domain and range for a function. The domain of a function is just all the x values that your function uses. So any x values that have points on the graph are going to be the domain, and the range is going to be the y values of the function. So all the y values for any points on the graph, okay? So that's kind of what domain and range are. Domain is the x values of the graph, and range is the y values, okay? Now, we typically, for this, we use a very specific notation for domain and range for just how we kind of represent it. We usually kind of use kind of like a coordinate pair, kind of like this right here. There's like a bracket, a 5, and then comma 8. What this means is this means all the numbers in between 5 and 8, okay? But the bracket here means we're going to include 5, and the parenthesis here means we're not going to include 8. So that's kind of what that means. Basically, parentheses on your interval notation means we're not including, if I could spell, the endpoints, or endpoint, whichever endpoint you're dealing with. And then a bracket means you are including the endpoint in your domain, okay? Or range. Okay. We'll do some examples of this here coming up. But basically, when you look at this 5, 8, the bracket is on 5, the parenthesis is on 8. This means all the numbers in between 5 and 8. So like 6 and 7 and 6.5 and 7.2, anything that's in between 5 and 8, and we are going to allow 5, so we're going to include 5, but we're not going to include 8 because that one has the parentheses on it, okay? And again, we use this to kind of represent our domain and range. I'll show you an example of that here shortly, okay? Let's look at this one, 3 to infinity, okay? What does that mean? Well, this is just all the numbers from 3 up to infinity, and we're going to include 3 because there's a bracket on that one. There's a parenthesis on the infinity, so we're not including infinity, which should always be the case. You should never include infinity in your answer, okay? So this would be greater than 3, and it's going to be including 3. Including 3, okay? So it's including 3 because there's the bracket there, okay? So it's basically any number that's bigger than 3. It could be 3, okay, because of the bracket. But for instance, like -1 wouldn't be in this set because it's less than 3. It's not kind of in the range between 3 and infinity, okay? So this is what this is meaning. And so we're going to use this to kind of represent domain and range of our functions. Let's just do a few more examples. How could you represent all numbers using interval notation? So if you want any number that you could possibly get, what you're going to be using is -infinity to infinity, and you're going to put parentheses on both of them because you don't want to include infinity. That's not a number, okay? This would be all real numbers. Any number would be in between -infinity and infinity, and so that is how you would represent that. So basically, we just needed to talk about that first so that we're ready to kind of find domain and range. Let's go ahead and find domain and range for those two that we graphed earlier, okay? So we graphed x squared plus y squared equals 4, and then y equals x squared. What would the domain and the range of these two, well, not functions, but relations be? So the domain is the x values that have points. So if we look at our circle here, which x values are we using? You kind of just think about projecting the graph down onto the x-axis. Okay, so just bringing down those points on the x-axis, okay, and those are the x values that you're hitting, right? So notice out here, like out at 6, for instance, there's not a point with x equals 6, and so that is not part of the domain. It's only the things in here from, it looks like from like -2 to +2, right? That's the domain. Those are the x values that actually have points with them, okay? So how we would write our domain is we start out, the smaller one is -2, and then we go up to 2, okay? Do we include those two in the answer? Do I need a parenthesis or a bracket around these two? Well, it does actually equal -2 out here on the end, and it does equal +2 out there on the end. So we are including both of them, and we would just put brackets around it. Okay, so from -2 to +2 is the domain, and we are including both of those because, like, it looks like -2, 0 is a point, and then +2, 0 is a point, and so that would be your domain. Okay, so domain is just the x values. Range is the y values. So how you do that is, instead of projecting things down to the x-axis, what we're going to do is project it down to the y-axis, okay? So, well, kind of to the side. So it's all of this region. Notice if I go like over here on the y-axis, there isn't any points up there with a y value up there, right? So it's only the y values in between here and here are the ones that get hit. So again, it's down from -2 up to 2. So we just do -2 to 2, and both of the endpoints do get hit. So we're going to put brackets around those. So that's the domain, and that's the range of this relation. Okay, so domain is x values, range is y. These ones are the same because it's a circle centered at 0, 0, so it's kind of symmetrical, right? But some of them, like this next one, it will be a little bit different. Okay, so that's domain and range. Let's try it for y equals x squared. So we have this parabola here, y equals x squared. Okay, we want to find the domain. Domain is the x values. So what you're going to do is just kind of project these points down onto the x-axis. Okay, what points get hit when you project them down onto the x-axis? Well, even if you go like out here, eventually, like this is going to keep shooting up over here, right? Eventually it is going to have a point over there, right? And so over here as well, even like out here at -10, there's going to be a point out there. It's just going to be really high up, right? In fact, it'll be, I think, at 100, if I'm not mistaken, like that. So anything on the x-axis is going to have a point with it, right? When we kind of project this down. And so the domain for a y equals x squared one is just -infinity to infinity. Any real number will work, okay? And we want to use parentheses around those because we can't include infinity. It's not a number, okay? So that would be our domain on this one. Now, range is a little different, right? That's just the y values. So when you look at the y values, we're just projecting over horizontally to the y-axis. It's this region right here, right? Notice down on this part of the graph, on those y values, those ones don't have any points down there, right? And so it's only up here we have points, so it's just these y values that are the y values, okay? So let's see, what's the lowest y value? It's right here at 0. And then the highest y value, it just keeps going up to infinity, right? So we go 0 to infinity, okay? Now 0, do we want to include it? Well, yes, we do hit 0. There is a point with y value 0, so we're going to include that with brackets, okay? Put brackets on that one. And then it goes up to infinity. Do we want to include infinity? Well, infinity is not a number, so we're not including that one. It would just be a parenthesis. Okay? So that's how you would find your domain and range for these functions. Well, only one of them is a function. The circle is not a function, but anyway. That's how you would find the domain and range of these relations. Okay? I want to just do a few more examples here real fast to hopefully get you familiar with this, but hopefully that kind of helps. I'm going to fold this over, so you might want to pause the video if you're still looking at it. Okay, let's do a few more examples. Well, now let's do x minus 2 squared, and then y plus 3 squared equals 4, okay? Now, this one, what type of graph is this? Well, look at it. There is x squared, right, and a y squared, so this is going to be a circle, okay? So this is a circle. That's a circle, okay? What's the radius of our circle? Well, we take this number over here, the 4, and we square root it. So the radius is just 2 on this circle, okay? Now this one, is this centered at 0, 0? This x minus 2 squared plus y plus 3 squared? No, because we have these other numbers in here, right? And remember, to find the center, you have to do the opposite of both of these. This is going to move us right 2. This is going to move us down 3. So we just do the opposite of whatever those are, right? Right 2, and then down 3. 1, 2, 3. So right 2 and down 3 is where our center is, okay? And then the radius is 2, so we just need to go out 2 in all directions. Okay, so 1, 2, 1, 2, 1, 2, 1, 2, like this, okay? And there is our circle, okay? So that's the graph of our circle, okay? It's just centered at positive 2 and negative 3 now, okay? So what happened to our graph of x squared plus y squared equals 4 to get our new graph? It went 2 to the right and 3 down. 3 down. That's how we got our new graph, okay? Now, let's find our domain and range. Now, domain, again, we're just kind of projecting our image to the x-axis. So wherever there's points, we're just kind of projecting those, in this case, up to the x-axis. So it's just in this range right here, we have points, right? But like out here, over on this side, we don't have any points for the graph, right? It's just kind of in this chunk right in between that we have x values for our points, okay? So it's from 0, it looks like, all the way up to 4. Okay, so from 0 to 4 is the domain. Do we want to include 0 and 4? Well, yeah. Those are the two endpoints, so they do get hit. So it would be 0 and 4 with brackets. Okay, that would be our domain. Our range is going to be the y values, so we just project over to the y-axis, all kind of our points, and then we see what gets hit. Well, It's like there, right? Sorry, that's not a great picture, but it's from -1, right? It starts at -1 and then it goes down all the way down to, I think it's -5 right there, right? Now technically we like to go from lowest number to highest number. So we'd actually want to start at -5 and go up to -1. So -5 up to -1. And then we are including those because those are hit by a point. But those are the only y values that actually have points associated with them. Like right up here, there's no points on the graph up there. There's no points down here. It's only in this range right there that we actually have points. So from -1, or sorry, from -5 to -1, that's our range. Okay? Let's do another parabola, kind of a shifted parabola. And yeah. So let's look at y equals x plus 1 squared minus 4. So this, what type of graph is this? Is it a circle? Well, not quite. Notice the y isn't squared here. It's not y squared. This one had y squared, so that one's a circle. This one is just a parabola, okay? Now, similarly to the other one, what we're going to do here is it's going to get shifted around, right? What happens to this graph when you have this +1 in here? Well, it's kind of similar to the circle. The +1 is going to move us left 1. Okay, so we are going to go left 1. Okay, the -4 though on the outside here, okay, notice this -4 is outside the square. Here, this 3 is inside right next to the y, and that's what is making it do the opposite. It went down 3. So this one is going to do actually the same thing as the sign. It's not going to flip, it's just going to go down 4. Okay, so you don't need to flip this one because it's not right next to the y. It's like over here on the other side of the equation. So this one goes left 1 and down 4 from the original graph. So we could graph that. Normally we start at 0, 0, so we just go left 1 and down 1, 2, 3, 4. So that's our new kind of vertex of the parabola, is right there at -1 and -4. And then remember, kind of your typical parabola goes over 1, up 1 on both sides, where there's not a stretch factor there. It goes over 1 and up 1 on both sides, like kind of like this. I'm just drawing a rough sketch. But over 1, up 1, over 1, up 1 on both sides. Okay? And that is your parabola. Okay? So that's y equals x plus 1 squared minus 4. It's a parabola. Let's go ahead and find domain and range. The domain is, what are the x values that work when you project it down to the x-axis, right? Basically everything is working because even out here is going to have a point clear up off the graph, right? So domain is -infinity to infinity. Excuse me. The domain is -infinity to infinity. And then let's find our range. The range is where we project onto the y-axis. I'll use a different color here. So all of this is getting hit. What's the lowest y value we have? Well, it's right at the vertex. It's right down there, right? And then it goes up from there, right? There's nothing down below the vertex. So it's from -4, and then it goes up all the way to infinity. Okay, so -4. Oh, and sorry, we should have a bracket on the -4 because we are including -4. It does get hit at the vertex. Okay, And that's our range. Oh, home on the range. Anyway, so that's graphing your parabola and finding the domain and range, okay? So we have graphed parabolas before, okay? Kind of the tricky thing here is that you don't have to switch the sign on the one outside, right? Only the ones inside next to the variables do you have to kind of do the opposite of what you might think, okay? Okay, I think that's most of the ideas for today. I'll just do a few more examples to make sure we got it, and then we'll be good here, okay? Few more examples. I'll just maybe do two more, well, maybe three more, depending on how much time we have. Okay, so we have x minus 1 squared plus y plus 4 squared equals 9. Okay, what type of graph is this? Is it a circle or is it a parabola? Well, look at where are your squareds. Is the y getting hit with a squared as well as the x? Yes, both x and y are squared. So this is going to give us a circle. What's the radius on this circle? It's the square root of 9 is 3. Okay, so radius of 3 for this circle. And then this minus 1 here means I go to the right one. I go right one, and then this plus 4 there means I do the opposite. I go down 4. 1, 2, 3, 4. Right there. Okay, so that's my center of the circle. And then radius of 3 means I go out 3 in all directions. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so we go out. This tells us the center, those two. This tells us the radius, which is 3. And then we just go out the radius in all directions and sketch our graph. It's just a nice circle here. The circle of life. Okay, let's find the domain and range of this circle of life. Okay, domain is going to be the x values, so it's from here over to here, right? It's just these x values have points. The other ones don't, so -2 to 4. Okay. From there to there is the x values that have points, okay? And then the y values that have points are like from here down to there, right? So I think it's from like -7 is the bottom one, it looks like. And we are including -7 up to -1. Okay, and that's our range. Okay, so we have our circle with its domain and range. Okay, okay, let's do one more. We have here an x plus 2 squared minus 3. Is this, and y equals that, is this going to be a parabola or a circle? Well, this one you'll notice doesn't have y squared, so this is a parabola. Okay, this is going to look like a U. Okay, this number right here tells us we go left 2. We do the opposite of that one. But notice this one isn't next to the y, so we do exactly what it is. We go left 2 and then down 3. So left 2 and down 3. 1, 2, 3. That's where our vertex of our new parabola is. And since there's nothing out in front, it just goes over 1, up 1, over 1, up 1 on both sides, like so. And that's kind of our U shape. Okay? Now on this one, what's our domain? What x values work? Well, basically anything, right? Because it keeps shooting off. So negative infinity to infinity. Actually, like any quadratic, any parabola is going to have a domain of negative infinity to infinity, okay? But the range will be a little bit different. Range is the y values, so we're just kind of tracing over our y values. And what is getting hit? Well, it's everything up from the bottom. So from the bottom of the parabola, the bottom of it is at negative 1, 2, 3, right? It's at negative 3, and then it goes up to infinity, okay? So we do negative 3, we are including negative 3, and then up to infinity, and that's our range, okay? So there's another one where we found domain and range of our circle and our parabola, okay? Few last things that I want to look at here just before we're done. I have a few more examples of this, but I feel like I've spent enough time on this. If you need more help, you can ask me during class. I do want to look at some cases where we have parabolas that are maybe not as nice. Okay. Okay. So we have some parabolas here. We have y equals 3x squared plus 1. We're going to start with this one, okay? Notice there's a 3 out in front of the x squared, a 3 timesing, okay? Now what's that going to do to the graph? It doesn't actually move it up or down at all. It just kind of makes it tighter or wider, okay? This one gets tighter. This plus 1 on the outside here, that means we're going to go up 1, okay, because we don't have to do the opposite where it's outside there. There's nothing in there with the x, so all we have to do on this one is go up 1. We don't have to do anything else, okay. That's our new vertex, is we just go up 1, okay, and then 3x squared. Now typically when we've been graphing these before, we went over 1, up 1 on both sides, right, or up 1 over 1, either way, right? Now for this, where there's this 3 out here, that's going to be timesing our distances by 3. So typically I go over 1, up 1. We're now, instead of going up 1, we're going to go up 3, okay? So up 3, 1, 2, 3, over 1, okay? And then up 1, 2, 3, over 1. So it's just kind of a tighter parabola. So you always are going over 1, but this number just tells you how much you go up, okay, or down for that matter, okay. So that would be our graph of this one. Let's find the domain. Again, domain for a parabola is negative infinity to infinity because all of the x values are okay. Range, we start down here and then we go up from there, right? So nothing down here is in the range. It starts out at 1 and goes to infinity, and that's our range, okay? Now, something I should mention that we haven't talked about here yet is just if you do have a parabola, it will have a maximum or a minimum, right? This one has a minimum, right? Because it has like a bottom point. Minimum just means the lowest point. So the minimum of this one is happening at 0 and 1, right? That's your minimum, okay? Now that's something they could ask kind of depending on the type of problem that you're dealing with, is like for the max or min, okay? I do want to do one that has a maximum as well, and then that will kind of be our last one for today. We have this other one here, negative 2x plus 1 squared, okay? The negative 2 out here means that instead of going over 1, up 1 on both sides, we're going to go over 1 and then down 2, right? So that's kind of what's going on here. This plus 1 inside, what is that doing to our graph? It does the opposite because it's inside next to it. We're going to go left 1. So left 1. That's where our new vertex is. And then this negative 2 is impacting kind of how wide it's opening. It goes over 1 and then down 2. Over 1 and then down 2 on both sides. And that's our new graph. Okay. Over 1 and down 2 from both sides, right? So why is it left 1 and not like up 1 or like down 1? Well, the 1 is in there next to the x, and so that means it's affecting x, and it's going to do the opposite because it's inside with the x. So we're going to go left. Okay, this one was going up because the 1 wasn't inside with the x inside the square, right? It's outside the square, so that's going to kind of be affecting the y. Okay. So let's find domain and range on this one, and then we'll call it for today. Domain, again, is going to be negative infinity to infinity. All the x values are okay here. Range goes from the bottom here, right, all the way up to 0, right? Anything in this range works, but anything up here doesn't. So it goes from, we don't want to include negative infinity. It goes from negative infinity, the bottom of the graph, up to 0. We do want to include 0. Okay, and that's our range. Okay. This one has a maximum, right? A top. The top is just at negative 1 and comma 0. Okay, that would be our maximum for this graph. So hopefully you're kind of getting a hang of this graphing thing. Okay, it just takes a little bit of practice, but you'll get there. Today, mostly was just review, because we've done circles, we've done parabolas before. It's just the new thing is kind of finding domain and range, kind of these things that we like to sometimes have about a graph. Okay, so I think that is it for today. I'm going to go ahead and stop the video, and I'll see you guys in the next one.